information. In the How to Use Technology to Write and Publish by Sarah Howell, Discover Technology. Have you used a computer or sent a text message today? Have you ever used the internet to write a report for school? Computers, cell phones, and the internet are all forms of technology. Technology has changed the way we get and share information. In the past, students had to read through many books to find information on a topic. They wrote pieces either by hand or with a typewriter. Sharing a piece of writing meant making copies and handing them out. Today, all of that can be done with a few clicks of a mouse. Technology has not only made it easier to write pieces, but also made it easier to share what you have written with others. Digital literacy. To take full advantage of new technologies, you will need to learn a new set of skills. These skills are often called digital literacy. Literacy is the ability to read and write. Digital literacy involves finding, sorting, and creating information on computers. An important part of digital literacy is thinking critically about the information that you find. You will need to decide if information is useful to your project and whether it comes from a source that is credible or truthful. You should also know how to cite a website where you find information. Ready for research. The first step in digital literacy is knowing where to look for information on a topic. If you are using the internet, a search engine is a great place to start. Begin by searching for keywords and ideas. If you are looking for information about zebras, you might type zebra diet or zebra habitat into the search engine. You will likely find lots of information on the internet. Not all information comes from credible sources, though. Websites run by zoos, museums, and the U.S. government are good places to find information that is true and up to date. Taking notes. As you read through websites, remember to take notes. You can even use a computer or tablet. Start by opening a blank document on your screen. When you find a useful fact on the internet, click over to the document. Type a few keywords that will help you remember the fact. You can also bookmark any websites that you may want to come back to later. When you have the information you need, organize it and plan your piece. You can cut and paste your notes so related information is grouped together. Then open up a new document and start writing. Draw it out. Your piece of writing should convey ideas and information as clearly as possible. You might find that some information is easier to understand when it is shown as a graphic organizer, photo, or illustration. For example, if you are writing about population growth in your state, you could use a graph to show changes over time. If you describe the features of a platypus, a photo can help readers visualize the animal. You can create your own graphic organizers and illustrations on a computer using drawing programs and online templates. You can then paste these illustrations right into your writing document. Fixing up. When you have written your piece, check it for any mistakes in spelling or grammar. Finding and fixing these mistakes is called editing. Many computer programs will underline or highlight spelling mistakes and sentences that do not use proper punctuation. You should also reread your piece as if you were seeing it for the first time. Does it flow or move well from one idea to the next? Do not be afraid to revise or change any parts that do not make sense. Using technology to edit and revise keeps you from having to rewrite your entire piece by hand. Making connections. Have you ever worked on a group writing project? In a group project, everyone does a certain job. Technology can be very useful for researching and writing as a group. Group members can use email to share their work with each other. They can also use video chat to talk over ideas and ask questions. Technology can also help you get feedback on your writing from others. Feedback can include notes, edits, and suggestions on how to make your piece better. See if your teacher will set up a website where students can give each other feedback on their work. Spread the word. Some people write simply for themselves. Most writers, though, write with the hope that others will read their work. When someone prints a piece of writing so that other people can read it, it is called publishing. There are publishing companies around the world that print the work of professional writers. You do not need to be a professional to share your writing with others, though. Computers make it quick and easy to print pieces of writing. You and your friends might enjoy working together to write and print out a book of short stories or poems. Digital publishing. In the past, publishing meant printing a piece of writing on paper to share. Today it means something else, too. Writing can be published on the internet and shared with the world in seconds. There are many websites where you may be able to share your writing. See if your school has a website that publishes student work. You can also search the internet for writing contests for kids. With a parent's permission, you could even start your own blog. You can continue to post new writing on your blog and get feedback from people around the world. When you publish your work online, it is easy to share with friends and relatives who live around the world. Publishing passion. When we think of published writing, we often think of stories and poems. You can write and publish any type of writing that interests you, though. Try starting a family newsletter and emailing it to family members who live far away. If you have an idea for how to make your community a better place, email a local politician. If you love koalas, create a book about them for a younger sibling. Today's technology makes it faster and easier to write and share work than ever before. How to gather information, take notes, and sort evidence. Sarah Howell. Starting at the beginning. Imagine your teacher asked you to write a report on grizzly bears. How would you begin? First, you would find out everything you could about the topic. Then you would decide which information was important. Finally, you would sort the important information into groups and begin writing. As a student, you will often be asked to present information in explanatory texts. Some topics you write about may be familiar. Others will be completely new to you. Learning how to gather information, take notes, and sort evidence will help you plan and organize your texts before you even begin writing. Gather the information around you. Before you begin gathering information on your topic, you must first know where to look. In some cases, your best information might come from asking people questions and recording their answers. This is called an interview. You could interview your parents to write a piece about your grandmother's life. In other cases, you can gather information by observing the world around you. If you were writing about the weather in your neighborhood, you could keep a journal of each day's clouds and rainfall. If you were writing about stars, you could use a telescope to observe their movements in the night sky. The printed word. Books and other printed sources, such as newspapers, are great places to find information. Whatever your topic, there is probably a book about it. Find books written for your age and reading level. Encyclopedias cover a wide range of subjects, usually in alphabetical order. Newspaper articles are great sources for information about current events. Sometimes, sources may disagree on certain facts. An older book may say one thing, while a newer book will give you newer and more accurate or correct information. It is important that you always compare sources. Try to find at least 2 sources to back up any facts you use. Digital sources. Books may take many months to be published and make their way to your local library. The internet carries information to your computer in seconds. This can make the information very up-to-date. Finding information on the internet is similar to searching in a library. You need to know where to look. Begin by typing your topic into a search engine, such as Google. The search engine will give you a list of websites related to the topic. Some websites may ask you to register before you can see the site's information. Never put any personal information online without an adult's permission, though. Adding extra words to a web search can narrow your results. Typing jaguar animal will make sure you get websites about the wild cats, not the car company of the same name. Facts and fiction. The internet is full of useful information. However, it is important to understand that not all the information on the internet is true. When you are gathering information, look for websites run by credible sources. These can include museums, zoos, and the U.S. government. For example, if you are looking for information about energy usage, try starting with the website run by the Department of Energy. The ending of a website's address is a useful clue to decide if it is credible. Government websites end with .gov. Nonprofit groups use .org. And college and university websites end with .edu. Taking notes. As you read through books and websites or conduct interviews, it is important to write down useful facts that you see or hear. This is called taking notes. Your notes should be brief or short and include only the most important information. Keeping your notes organized will make it easier to sort or group the information later. An outline uses letters, numbers, or bullet points to list ideas and facts. You can also use pens with different colored ink to organize ideas. For example, facts about an animal's diet can be written in blue and facts about its appearance in red. Writing tip. Do not worry about writing incomplete sentences when taking notes or making an outline. Just write down key words and ideas. Sorting evidence. Once you have gathered your information in brief notes, it is time to sort it into categories or groups. One way to do this is to use index or note cards. Think of each index card as a separate paragraph in your report. What questions would you like the paragraphs to answer? If you are writing about insects, you might have questions such as, what do insects look like? And where do insects live? Write each question at the top of an index card. Then read through your notes and copy down the facts that answer the question. In your own words. How would you feel if one of your classmates copied your report and handed it in as her own? Taking someone else's work and calling it your own is called plagiarism. Plagiarism can be cutting and pasting an entire article or copying just a few sentences. Though it may seem harmless, plagiarism is actually a form of stealing. To avoid plagiarism in your writing, always name your sources. If you learned from a book that emperor penguins live in Antarctica, list that book as a source at the end of your report. This list of your sources is called a bibliography. Working together. Sometimes teachers will assign a small group to work together on a research and writing project. Working with others is a fun way to learn from each other and share responsibilities. As you begin your project, get together and talk about each group member's strengths. One person may be good at taking notes. Another may have strong keyboarding skills. You can use these strengths to divide the work and decide on everyone's role or job. Make sure the work is shared equally and everyone understands what he or she needs to do. As you work together, listen to each other's ideas, problems, and questions. Sharing your finished piece. The more you practice gathering information, taking notes, and sorting evidence, the better you will become. These skills will help you write a report that is organized and conveys ideas and information clearly. When your report is finished, you can use technology, such as computers and the internet, to share it with others. Try starting your own website about your topic. Other students may even use your website as a source for their own reports. How to write a narrative. Sarah Howell. What is a narrative? A narrative is a piece of writing that tells a story. Narratives are written for people to enjoy while reading them. They can also teach lessons or morals. Some narratives, called fiction, are about imagined or made-up people and events. Other narratives tell true stories that really happened to the writer. These are called personal narratives. Narrative writing gives you the freedom to make many choices. Your narrative can be as long or as short as you like. The story can take place over just a few minutes or over many years. When you write a narrative, you are in charge. Who's who? All narratives are about individuals, called characters. Your characters can be people, animals, space aliens, or anything else you can imagine. Your story can have just one character or many. A character who explains to the reader what is happening is called the narrator. Introduce your main characters at the beginning of the story. Use details to show readers why a character is different or special. You could write that Mr. Jenkins is the town librarian, or that Greta is the tallest girl in her school. Spend some time thinking about who your characters are before you begin writing. Explain how the characters in your story know each other. Are they friends, siblings, neighbors, or something else entirely? Creating conflict. Once you have characters, your story will need a conflict or a problem. For example, your character Michael could find out that his best friend is moving or that his mother is having another baby. Your character's actions will create the plot or events of the story. After each event, ask yourself, what would Michael do next? The plot should unfold in a clear and natural event sequence. A sequence is the order in which things happen. The better you know your character's thoughts and feelings, the easier it will be to decide what he would do after each new event. Descriptive details. Strong narrative writing uses many effective techniques, or ways of doing things. One of these techniques is using descriptive details to help readers picture a person or a place. If you were to say, Ms. Withers was ugly, different readers might imagine the character in many different ways. Instead, you could write, Ms. Withers had yellow, rotting teeth and a giant red blister on her forehead. These descriptive details give readers a clear image of the character. Descriptive details can also include more than just what you see. Use all 5 of your senses to describe the world of your story. Showing action. To keep your story moving forward, it needs to have action. Words that show action, such as run and jump, are called verbs. Good action words give readers a clear picture of what a character does and how he feels. It is often more interesting to show actions instead of explaining feelings. The sentence, Marcus was bored, tells readers how a character feels as he sits in class. Instead, you could write, Marcus watched the ticking clock. He tapped his pencil on his desk. Readers will be able to guess from Marcus's actions that he was bored. Speak up. People often share their thoughts and feelings by talking. The characters in your story should get the chance to speak, too. When characters talk to each other, it is called dialogue. Like action words, dialogue lets you show, instead of tell, what a character is thinking or feeling. Writing dialogue that sounds real takes practice. The next time you are on the bus or waiting in line, listen to the people around you. Pay attention to how they speak and the words they use. Try writing down interesting things you hear and putting those lines of dialogue in your story. Temporal words. As events occur in your story, it is important to show the order in which they happen clearly. Temporal words can help you do that. The word temporal means having to do with time. Temporal words are words that show time, such as first, next, and after. Temporal words give readers signals or hints about the story's event sequence. Temporal words are useful as transitions between paragraphs. Try starting a new paragraph with a temporal phrase such as the next day or after that. This shows readers that time has passed between the last event and the next one. Ending your story. The way a story ends is just as important as how it begins. Try to give readers a sense of closure or a satisfied feeling. Did your character get what she wanted? Did she learn any lessons? One effective technique is to end your story with a strong feeling, image, or action. Say your story is about Alex's best friend moving away. Your narrative could end with the sentence, Alex smiled and looked at the letter in his hand one more time before he dropped it in the mailbox. Readers feel closure knowing that Alex is happy and will keep in touch with his friend. Using technology. Technology, such as computers and tablets, makes writing and sharing your narratives easier than ever before. Computers allow you to go back and edit or change parts of your story without rewriting the whole thing by hand. Certain computer programs will also point out spelling and grammar mistakes. When your story is finished, use email to send it to friends and family members who live far away. With your parents' permission, look online for writing contests you can enter. Do not just worry about winning, though. Remember, stories are written so they can be read and enjoyed by others. Reading and writing. Narrative writing can be a lot of fun. When you write a story, you decide who and what it will be about. You can write about your own life or create new worlds. Reading narratives by other people can help you become a better writer. Think about the characters, event sequence, and descriptive details in your favorite book. Did the author use a certain technique that you liked? When you write your own stories, use what you have learned from others' strengths and mistakes. How to write an explanatory text. Sarah Howell. What is an explanatory text? Suppose a friend asked you how soccer is played. What would you tell her? You might start by explaining that soccer is played with a ball. You could tell her about different player positions and how points are scored. You could finish by explaining that the team with the most points wins. Writing an explanatory text is a lot like answering this sort of question. Explanatory texts give information about topics. In school, your teacher might ask you to explain how clouds form or why the American Revolution was fought. A good explanatory text examines a topic and conveys ideas and information clearly. Explanatory texts are a great way to learn more about topics that interest you, from parrots to paintball to Parmesan cheese. Introducing your topic. It is important to let readers know what your explanatory text is about right away. This helps them decide if it is something they would like to read. You should introduce or present your topic in the first few sentences. This first paragraph or section of your piece is called the introduction. The introduction is also your chance to get readers interested. Including a fun fact about your topic is a great way to do that. In a piece about how ice cream is made, you might begin by saying that each American eats nearly 6 gallons, 23 liters of ice cream every year. Facts, definitions, and details. The body of your piece gives readers information or facts. Facts are statements that can be proven. Poodles are the best pets is not a fact. Someone else may think goldfish make the best pets. Neither idea can be proven right or wrong. Poodles are a kind of dog, though, is a fact. Details or extra facts give even more information. If you write, poodles come in 3 sizes, a good detail might be that those sizes are called standard, miniature, and toy. If you use words that might be unfamiliar to your readers, include definitions to explain what those words mean. Ready for research. There are probably some topics that you already know a lot about. Others, however, will be unfamiliar. To write an explanatory text about an unfamiliar topic, you will need to research or study the topic and gather information. The best way to begin your research will often depend on the topic. If you are writing about reptiles, an encyclopedia or a website run by a zoo would be good places to start. If you are writing about your grandfather, though, your best sources of information would likely be members of your family. Grouping information. Before you begin writing, organize your information. Look for facts that have some kind of connection. For example, if you were researching the state of Florida, you would learn that more than 19 million people live there. You would learn that the Florida city with the most people is Jacksonville, and that most of the oranges sold in the United States are grown there. These first 2 facts are both related to the state's population. They can be grouped together in one paragraph. The third fact has to do with the types of crops grown in Florida and would fit best in a different paragraph. Picture this. Have you ever heard someone say, "A picture is worth 1,000 words"? Illustrations are a great way to help explain and examine your topic. They can even help you organize your information before you start writing. Try using maps, graphs, charts, and diagrams in your piece to aid readers' comprehension or understanding. Choose the type of illustration or graphic organizer that makes the most sense for your topic. A diagram is a good way to show the water cycle or an animal's life cycle. Graphs can show changes over time. Maps are useful for showing where animals or people live. Linking ideas. The body of your explanatory text will list many facts. Linking words help connect these facts. Words such as also, another, more, and but connect ideas within groups of information. Look again at the fact about the number of oranges grown in Florida. Linking words can connect this fact to facts about other crops grown in Florida. For example, you could say that 74% of oranges sold in the United States are grown in Florida. Florida also grows more green beans than any other state. Strawberries are another crop grown in Florida. The words also and another here connect these facts and ideas together. Wrap it up. The last section of your explanatory piece is called the conclusion. This short paragraph is where you conclude or end your piece. You can start by writing a short summary of your main ideas and key details. Be careful not to repeat yourself, though. You do not need to add new information. However, you should state your information in a new, interesting way. Use your conclusion to show readers why they should care about your topic and why it is important. A good conclusion can excite readers to start their own research and learn even more. Your conclusion is a great place to make an argument for the importance of your topic. Put technology to work. Technology is all around us, from computers and tablets to email and the internet. Did you know you can use these tools to research and write your explanatory piece and then share it with the world? Using technology may even help you become a better writer. If you write about a topic that really interests you, you may want to start a website or blog about it. If your classmates or friends write their own pieces on different topics, think about creating a website together. You might end up teaching people around the world about your topic. Mastering skills. Much of the information we learn comes from explanatory pieces, such as textbooks. Learning to write a well-organized explanatory text of your own can help you identify main ideas and connections in the texts you read. Learning to convey ideas and information clearly in your writing is very important too. The steps and tips in this book can help you master this skill. Writing clear and organized explanatory texts is a skill you can use for the rest of your life.
Earth, the Water Planet, by Greg Rosa. The Water Planet. We live on planet Earth. Earth is one of 8 planets in our solar system. Scientists think that the solar system formed about 4.6 billion years ago as a cloud of gases and dust. This cloud began to spin and fall in on itself. Over time, this caused the sun to form. The planets formed soon after. Earth is special. It is the only planet in the solar system with a plentiful supply of water. It is also the only planet that has life as we know it. Where did Earth's water come from? When Earth formed, scientists think that it was a dry lump of solid rock. This lump of rock had trapped many elements, including the gases oxygen and hydrogen. As Earth spun, some matter moved to the center of Earth and some moved to the surface. This released hydrogen and oxygen into the space around Earth. These and other gases formed the air around Earth. It also allowed the oxygen and hydrogen to join and form water. Life on Earth. Scientists know that life began on Earth about 3.5 billion years ago, but they are not sure how it happened. Many scientists think that life originated when chemicals in the oceans joined together with the aid of sunlight to form new chemicals. The new chemicals formed the types of matter that are found in all living creatures today. Living things need water to carry out the processes that keep them alive. Human beings are about 65% water. Some living things, such as a tomato, can be as much as 95% water. Reservoirs. A reservoir is a place where a large amount of water gathers or is stored. Natural reservoirs include oceans, lakes, rivers, and streams. Earth's ice caps and icebergs are also natural reservoirs. The oceans hold about 97.2% of all the water on Earth. Only about 2.8% of the water on Earth is fresh water. The ice caps and icebergs contain about 2% of the water on Earth. The other 0.8% can be found in the ground, in lakes, seas, rivers, and in the atmosphere. Wet Earth, dry Earth. Some parts of Earth's surface have more water than others. The Amazon rainforest in South America is one of the wettest places on Earth. It receives more than 100 inches of rain a year. Because of this, the Amazon rainforest is home to the most types of plants and animals found anywhere in the world. Few creatures can live in areas of the world where there is little water, like the Sahara Desert in Africa. The Sahara receives less than 4 inches of rain a year. States of water. Water can exist in 3 states, depending on how hot or cold it is. At room temperature, water is a liquid. which is something that takes the shape of the container holding it. When water is cold enough, it turns to ice, which is a solid. A solid is something that takes a specific shape and can be held in the hand. When water is heated enough, it boils. Boiling water turns into a gas called water vapor. Most gases have no shape or color. The water cycle. Water on Earth is always changing. Water in oceans, lakes, the ground, and even in living things changes into a gas and rises into the air. Once there, it forms clouds. The water changes into rain or snow and falls back to Earth. Much of this water falls directly into bodies of water. Some rain soaks into the ground and is used by plants. Some of the water runs off into bodies of water. From there, the process starts all over again. This process is known as the water cycle. The properties of water. Water is a universal solvent. This means that it can break down nearly every substance. Water has a high heat capacity. In other words, it is able to take in a large amount of heat while its own temperature only rises slightly. Water is made up of very tiny parts called molecules. These molecules cling to each other tightly. Because of this property, water is able to creep up the stem of a plant. The power of water. Water can act with great force to change Earth's surface. When water hits or rushes over land, it can shape the way the land looks. Over time, rivers cut paths through solid rock. They carry tiny pieces of rock, soil, and sand with them. These pieces are deposited at the ends of rivers, creating new areas of land called deltas. Deltas are usually perfect for farming. When too much rainwater or melting snow enters a river, the river can overflow and flood the area around it. Running water can also cause erosion to occur. Water and civilization. All civilizations depend on fresh water. The world's first civilizations appeared between the Tigris and the Euphrates rivers, in the area that is today known as Iraq. Today we depend on water for many uses. Not only do our bodies need water to live, but we also use it to farm, make power, travel on, and play in. Water is so important to us that we need to be careful not to pollute it. Polluted water is not safe to drink and takes a long time to clean itself.
Hurricanes by Doreen Gonzalez. Spinning and swirling. A hurricane is a huge storm of spinning wind and rain that starts over the ocean and sometimes moves onto land. A hurricane can be 300 miles, 483 kilometers wide. Its center, called an eye, is calm and clear. Wall clouds full of rain swirl around the eye, sometimes spinning at 200 miles per hour, 320 kilometers per hour. More clouds called rain bands swirl away from these clouds. Hurricane winds can tear buildings apart and make large waves called storm surges. The rains from hurricanes can cause flooding. They are dangerous storms that often kill people. Tropical cyclone, hurricane, or typhoon. Hurricanes form when warm air sitting on the surface of the ocean rises. More warm air rushes in to take its place. It rises too. As this movement continues, it can create swirling winds called a tropical depression. A tropical depression becomes a tropical storm when its winds spin faster than 38 miles per hour, 61 kilometers per hour. When the winds reach 74 miles per hour, 119 kilometers per hour, the storm becomes a tropical cyclone. Hurricanes are tropical cyclones that form in the Atlantic and eastern Pacific Oceans. Tropical cyclones in the western Pacific Ocean are called typhoons. Those in the Indian Ocean are just called tropical cyclones. How strong is it? Scientists name hurricanes as they form. This helps them keep track of several hurricanes at once. Hurricane names come from a list that is made years in advance. If a hurricane is very destructive, its name is never used again. Scientists estimate a hurricane's strength using the Saffir-Simpson scale. Category 1 hurricanes have 74 to 95 mile per hour, 119 to 153 kilometer per hour winds. They can break tree branches and cause flooding along coasts. Category 5 hurricanes are the strongest storms. They have winds greater than 155 miles per hour, 249 kilometers per hour. They can destroy buildings and pull trees from the ground. Katrina's wake. Hurricane Katrina was one of the deadliest hurricanes ever to strike the United States. It formed in 2005. Katrina first made landfall, or came onto land, in Florida. It then moved into the Gulf of Mexico and gained strength. Days later, Katrina slammed into Louisiana and Mississippi. Its winds ripped apart homes and created a storm surge that flooded land very far from the coast. Katrina hit the city of New Orleans especially hard. Several of its levees were destroyed. Water poured over them, flooding the city. Houses were washed away and entire neighborhoods ruined. Katrina left 1,833 people dead. A 4 and a 5. The deadliest hurricane in U.S. history hit Galveston Island, Texas in 1900. It killed about 12,000 people. Many of them were trapped on the island when the hurricane's Category 4 winds knocked down the bridges to the mainland. The hurricane nearly destroyed the island city of Galveston. The storm's winds blew over houses as a storm surge flooded the city's streets. Another powerful hurricane crashed into the United States in 1992. Category 5 Hurricane Andrew made landfall in Louisiana and Florida. Florida was hit the hardest. Andrew left 160,000 people homeless, ruined more than $25 billion worth of property, and killed 23 people. Ike and Irene. In 2008, a huge Category 2 hurricane caused deadly flooding in Texas and Louisiana. Hurricane Ike was 180 miles, 290 kilometers wide. It was blamed for 112 deaths. Another unusual hurricane hit the East Coast in 2011. Hurricane Irene first made landfall in North Carolina as a Category 1 storm. It then hopped up the coast, producing flooding and wind damage all along the way. Irene was the first hurricane to make landfall in New Jersey since 1903. The storm reached Vermont before it lost enough strength to be called a tropical storm. By then, it had killed 45 people. Hunting for hurricanes. Hurricanes do not move in straight paths. They zigzag here and there, picking up and losing strength as they go. Scientists use satellites and radar to track them. They then study their paths to learn more about what creates and feeds them. This helps them get better at knowing where the next hurricane might move. Some of the best information, though, comes from hurricane hunters. These are people who fly airplanes into storms, gathering information about air pressure, temperatures, and wind speeds. Sometimes they drop tools called probes right into the storm. Probes send weather information back to scientists for study. More and more power. Earth's climate has been growing warmer. Since ocean waters soak up heat from the air, they have been getting warmer too. The oceans then let some of the heat back into the air. This creates more warm air just above the ocean, which is exactly what hurricanes need to form. Scientists believe this increase in warm air will create hurricanes with stronger winds and more rain. In fact, this may already be happening. In a 2005 study, scientists found that the number of Category 4 and Category 5 hurricanes each year had nearly doubled since the 1970s. Be ready. Be safe. The National Hurricane Center watches for hurricanes and sends out warnings when one forms. If you live where hurricanes strike, always have an emergency kit ready. It should include food, water, a flashlight, and a battery-powered radio. During a hurricane, stay away from windows. Listen to news reports and be ready to evacuate or leave the area. Hurricanes can be deadly, but you can stay safe if you know what to do when one hits.
Oceans by Greg Rosa. Earth's oceans. Oceans cover almost 3/4 of Earth's surface and hold about 97% of Earth's water. There are 5 oceans: the Atlantic, Pacific, Indian, Arctic, and Antarctic. The Pacific Ocean covers almost 1/3 of Earth's surface. Earth's oceans are all connected by smaller bodies of water, such as seas and gulfs. Most of Earth's living things live in the oceans. The oceans are home to everything from tiny plants to the giant blue whale. Oceans and the water cycle. Oceans play the biggest part in the water cycle. The sun's heat turns some of the water in the oceans to water vapor. Water vapor rises into the air and forms clouds. Water vapor then cools and falls back to Earth as rain or snow. When it hits the ground, much of it forms streams and rivers, which eventually flow back to the ocean. Then the cycle starts over again. Salt water. Water found in the oceans and seas is called salt water. Salt water makes up 97% of Earth's water. Much of the salt in Earth's oceans comes from the erosion of rocks on land. Rivers break down rocks and minerals, which include salts, and carry them to the oceans. Less than 3% of Earth's water is fresh water. We use fresh water for drinking, bathing, and watering our crops. Oceans and Earth's weather. The oceans help to warm the air when it is cold and cool the air when it is hot. In the summer, ocean water takes in heat from the sun and stores it. In the winter, the ocean can release stored heat to warm the air. Ocean currents affect Earth's weather patterns. Currents are caused by warm water rising to the surface and cold water sinking below the surface. They are also caused by the movement of wind on the ocean's surface. The ocean floor. Like the land on the continents, the ocean floor has vast plains, tall mountains, volcanoes, and deep valleys. The deepest parts of the oceans are great cracks called trenches. When you step into the ocean, you are standing on part of a continent called a continental shelf. At about 600 feet, the continental shelf drops off to a steeper area called the continental slope. This area drops down over 2 miles to the ocean basin. The ocean basin is mostly flat land. Ocean creatures. There is a wide variety of plants and animals in the ocean. Plankton are tiny plants and animals that do not move by themselves. They drift with the ocean currents. The ocean has many animals that swim, such as fish, octopuses, and dolphins. Some ocean animals spend time on land, such as seals and turtles. Animals such as starfish, sponges, and coral have adaptations that enable them to cling to rocks, the ocean floor, and other animals. Sunlit zone. Scientists divide the ocean into different life zones. The top zone is the sunlit zone. This layer can reach down about 600 feet below the surface. It receives the most light from the sun. More than 90% of all the open ocean's creatures live in this zone. Sea plants need sunlight, so most of them live in this zone. Many animals of the sunlit zone feed on the plentiful plant life found there. This zone is home to many kinds of fish, mammals, and plankton. Twilight zone. The twilight zone lies between 600 and 3,000 feet beneath the surface. This layer is darker than the sunlit zone because less sunlight reaches it. Very few plants live in this zone because they cannot get enough light. Since there are fewer plants, there are also fewer animals. Fish living in the twilight zone eat other fish that live there. They may also swim up to the sunlit zone to feed. Twilight zone animals include some jellyfish, lanternfish, and sharks. Midnight zone. The midnight zone makes up about 90% of the ocean. No sunlight reaches the midnight zone. The water pressure is very heavy, and the water temperature is often very cold. Very few creatures can live there. The midnight zone reaches down to the ocean floor, which has cracks called vents. These vents release boiling water from deep within Earth's crust. Tiny creatures live around these vents. Other deep-sea animals, such as eel and tube worms, feed on these tiny creatures, adapting to life in the ocean. Over millions of years, creatures have developed adaptations for living in their surroundings. Some mammals, such as the elephant seal, can hunt for food underwater for 20 minutes before returning to the surface for air. The animals that live in the twilight and midnight zones can withstand great pressure and cold temperatures. Some fish that live in these zones are able to make their own light. These adaptations allow creatures to live in Earth's oceans.
Lakes by Jane Kelly Kosak. What are lakes? Lakes are large areas of freshwater or saltwater that are surrounded by land. Lakes store water when there is a large amount of rainfall. This water can be used when there is less rainfall. Large lakes are sometimes called seas. The world's largest lake is called the Caspian Sea. It is about 750 miles wide. It lies between Europe and Asia. The world's deepest lake is Lake Baikal in Russia. It is 5,315 feet deep and contains more water than any other freshwater lake on Earth. How do lakes form? Thousands of years ago, glaciers covered large areas of land. As Earth became warmer in these areas, the glaciers melted and moved, leaving hollows or holes in the land. The rain, melted ice, and snow that fell into these hollows formed lakes. Some lakes form in cracks in Earth's crust or in volcanoes that are no longer active. Water from rain, snow, rivers, streams, and underground sources flows downhill until it reaches these hollows, creating lakes. Other lakes form when a section of a river gets cut off from the rest of that river. Man-made lakes. Man-made lakes are usually formed by building a dam across a river. When the dam is finished, the river pools behind the dam and creates the lake. Man-made lakes are also made by making a hollow next to a river and then supplying it with water from that river. Water runoff from rivers and streams is usually greater in man-made lakes than in natural lakes. Man-made lakes also have greater changes in water levels. These differences cause sediment to build faster. This makes the life of a man-made lake much shorter than that of a natural lake. Lakes and the water cycle. Lakes, like streams, rivers, and the ocean, are part of the water cycle. The sun's heat causes water from Earth's surface to evaporate and rise into the air as water vapor. Water vapor forms the clouds in the sky. This water falls back to Earth as rain or snow. When it hits the ground, some of it runs off into lakes, streams, or the ocean. Then the cycle starts again. Freshwater lakes. The Great Lakes, located in the United States and Canada, form the largest body of freshwater in the world. They include Lake Erie, Lake Huron, Lake Michigan, Lake Ontario, and Lake Superior. Freshwater is very important to living things. Some of our drinking water comes from freshwater lakes. More kinds of plants and animals can live in freshwater because it holds more oxygen and has less salt than saltwater. Saltwater lakes. A saltwater lake can be as salty as or saltier than the ocean. The world's saltiest lake is the Dead Sea, which is about 9 times saltier than the ocean. A lake can become salty if its water evaporates faster than it is replaced. Saltwater lakes have little oxygen. This means that these lakes do not have as many plants and animals living in them as freshwater lakes do. The Dead Sea got its name because only a few plants can live in it, and no animals can live in it except a certain type of shrimp. What lives in a lake? Many different kinds of plants can live in a lake. You may also find animals such as crayfish, snails, or shrimp. Many different kinds of fish also live in lakes, such as bass, perch, pike, sunfish, or trout. Some mammals live in and around lakes, including otters and beavers. You may even find snakes in a lake. All of these animals' bodies are made to live in water. However, plants and animals may be different from lake to lake. For example, the only freshwater seal in the world lives in Russia's Lake Baikal. The life of a lake. Lakes are temporary bodies of water on Earth's surface. Lakes are always changing through a process known as lake succession. Lakes undergo a natural aging process. Sediment gradually builds up in the lakebed. As lakes fill in, vegetation begins to grow. This causes lakes to become marshes, wetlands, and eventually forests. How long this aging process takes depends on the lake's size and volume, how much sunlight it receives, the length of its shoreline, and the health of its environment. Pollution. Have you ever seen a sign near a lake that says you can't go swimming or fishing there? The lake might be too polluted. Some lakes are polluted with waste that people have dumped there. Lakes may also be polluted with pesticides and fertilizers from farms. Sometimes when a lake is polluted, the lake uses up its oxygen faster than it can produce it. Without oxygen, everything in the lake may die. Caring for our lakes. We depend on lakes for many things. They give us water to drink, plants and fish to eat, and places to fish and swim. However, today many lakes are polluted or are losing large amounts of water. You can do things to help take care of our lakes. You can recycle your trash and use less water.
You can turn off the water while you are brushing your teeth and make sure there are no dripping faucets in your home. By doing these things, you are helping our lakes live longer.
Earth's Coldest Places by Mary Griffin. Bundle up. Do you like cold weather? Do you like getting bundled up to go sledding, skiing, or ice skating? It gets cold enough in many parts of the world to freeze ponds and lakes. Some places get a lot of snowfall too. For those who enjoy winter sports, this can be a lot of fun. However, some places are so cold that not many living things can survive there, including people. Let's take a trip to some of the most interesting and incredibly cold places on Earth. Why so cold? Did you ever wonder why some places are hot while others are cold? The imaginary line that goes around the middle of Earth is called the equator. The sun points directly at places on the equator, so the sun's rays there are very hot. Places farther away from the equator are often cooler because the sun's rays hit at an angle. Ocean currents are also responsible for temperatures. Some currents carry warm water to locations that can make weather warmer there than at another place the same distance from the equator. Record breaker. You might not be surprised to know Antarctica holds the record for coldest place on Earth. Scientists announced in December 2013 that they recorded a temperature of minus 135.8 degrees Fahrenheit, minus 93.2 degrees Celsius, in eastern Antarctica. However, that temperature was actually set August 10, 2010. Instead of recording temperatures in person, scientists used data collected by several satellites over time to figure it out. Before this record, the lowest temperature on Earth had been set in another place in Antarctica. Vostok Station, a research center, measured a temperature of minus 128.6 degrees Fahrenheit, minus 89.2 degrees Celsius. Cold science. Temperatures in Antarctica are always very cold, way below freezing. Yet some people do live there, mostly to do scientific research. Antarctica has more than 40 research stations. Many are made up of special buildings that are raised above the snow and ice. When scientists travel outside to do work, they dress in several layers of special clothing. Hypothermia and frostbite are major concerns. Scientists may also need to put their tools in special cases so they don't freeze. Mars. There are also research stations in the Arctic, though the temperatures there aren't as low as Antarctica. The McGill Arctic Research Station, Mars, was founded in 1960 on Axel Heiberg Island in the Canadian Arctic. The average yearly temperature on Axel Heiberg Island is 5 degrees Fahrenheit, minus 15 degrees Celsius. Up to 12 people can stay at Mars to study glaciers, polar desert, and the kinds of life that can survive in such harsh locations. Scientists there also research climate change and its effect on the Arctic and the rest of the world. Coldest U.S. city. In the United States, the title of coldest city goes to Barrow, Alaska. In winter, the average low temperature is minus 20 degrees Fahrenheit, minus 29 degrees Celsius. It's not much better in summer. The average over the entire year is only 11 degrees Fahrenheit, minus 12 degrees Celsius. This city of fewer than 5,000 people is also the northernmost U.S. city. It's so far north that between late November and late January, the sun doesn't rise. Another reason for Barrow's coldness is the wind coming off the Arctic Ocean. A frozen city. A few cities claim the title coldest city in the world. Many people give that honor to Yakutsk, Russia. The record low temperature in winter there is minus 81.4 degrees Fahrenheit, minus 63 degrees Celsius. The average temperature in January is minus 34 degrees Fahrenheit, minus 37 degrees Celsius. How cold is this? Many people don't wear their glasses outside because they can freeze to their skin. However, More than 200,000 people live in Yakutsk. They dress in furs to keep warm, but rarely spend more than 20 minutes outdoors in the winter. Frigid Denali. Mount McKinley, or Denali, in Alaska is often thought to be the coldest mountain on Earth. Temperatures in the winter regularly dip below minus 40 degrees Fahrenheit, minus 40 degrees Celsius. Some people have recorded even lower temperatures. Denali is also North America's highest peak at 20,320 feet, 6,194 meters. That makes many mountain climbers want to get to the top, about 1,200 people a year. Strong winds and blinding snow often mean that climbers need to stop and pitch tents on their way up. Sadly, over 100 people have died trying to climb Denali. Icebox of the nation. Some people are proud to live in extremely cold places. 2 U.S. cities, International Falls, Minnesota, and Fraser, Colorado, went to court over which could call itself the icebox of the nation. This meant it's the coldest city in the continental United States. International Falls won. International Falls has an average yearly temperature of 37.8 degrees Fahrenheit, 3.2 degrees Celsius. It celebrates its cold weather with a 4-day festival called Icebox Days. People bowl with frozen turkeys, make snow figures, and ski by candlelight. No matter where people live, they try to make the best of their surroundings.
Earth's Rainiest Places by Bailey O'Connell. Rain, rain, go away. Have you ever had to stay inside all day because it was raining? Sometimes it may rain several days in a row. However, at some point, the sun comes out, so you can get outside to play again. There are some places on Earth where the rain doesn't stop for a long, long time. Would you want to live there? You'd have to live your life very differently. Read on to find out how people survive in the rainiest places on Earth. Mount Waialaealai. Mount Waialaealai on the Hawaiian island of Kauai was once thought to be the rainiest place on Earth. It rains about 350 days a year there, adding up to about 450 inches, 1,140 centimeters. That means its green slopes are much like a swamp. The mountain rises 5,148 feet, 1,569 meters above sea level, and is often covered with clouds. Mount Waialaealai's rainfall feeds Hawaii's only rivers, as well as several waterfalls. In fact, the powerful water traveling down the mountain has carved canyons into Mount Waialaealai's sides. Record breakers in India. Cherrapunji, a village in northeastern India, calls itself the wettest place on Earth. It averages 464 inches, 1,179 centimeters of rain a year. That's almost 39 feet, 12 meters. However, another smaller village about 10 miles, 16 kilometers away may be rainier. Mawseen Ram averages 467 inches, 1,186 centimeters of rain per year. Almost 90% of northeastern India's rain falls between May and October. During this time, a weather event called a monsoon takes place. Monsoon. A monsoon is a wind pattern that brings heavy rains. Monsoons are caused by temperature differences in the air over land and sea. In summer, hot air over land rises. Cool air over water then rushes in to take its place. This air is full of moisture from the sea. It warms, rises into the air to form clouds, and then falls as rain. The winds that bring rain to Cherrapunji and Mawseen Ram are called the southwest monsoon. It blows off the Bay of Bengal. Puerto Lopez. Recently, a town in South America has been crowned the rainiest place on Earth. Puerto Lopez is found near the western coast of Colombia. Between April 1960 and February 2012, it received an average rainfall of more than 507 inches, 1,288 centimeters a year. That's more than Mawseen Ram in India. Puerto Lopez's location between the Pacific Ocean and a mountain range is the reason for its amazing amount of rainfall. The mountains to its east stop rain clouds from traveling further inland. Where does the rain go? Since some of these rainy places receive many, many feet of rain each year, you might wonder what happens to all that water. It either seeps into the ground or becomes runoff. Runoff is the water that flows over the land and into rivers, lakes, and oceans. There, the rain evaporates to become clouds, and the cycle continues. However, in some places, the rain can't seep into the ground, or can't seep fast enough. It might not be able to flow into rivers and lakes either. That's when floods occur. Rain's effects. In many parts of India, monsoons are welcome to break the hot, dry weather and provide water for farms and everyday life. In the dry season in parts of India, people must walk miles for water. But monsoon flooding can sweep away an entire community, so the rains are feared as well. Around the world, people fear flooding due to extreme rainfall. Even a small amount of floodwater can knock people off their feet, ruin houses and cars, and make water unsafe for drinking and bathing. Rainiest in the United States? There are some very rainy cities in the United States, too. In the South, Mobile, Alabama gets a bit more than 65 inches, 165 centimeters of rain a year. In the Northwest, Astoria, Oregon receives 67 inches, 170 centimeters of rain each year, while Forks, Washington gets close to 99 inches, 251 centimeters. However, the location of the wettest U.S. city may surprise you. Hilo, Hawaii averages more than 127 inches, 323 centimeters of rain a year, thanks to the moist air of the Pacific Ocean. Climate change. Many scientists think that climate change is causing more rainfall. As temperatures around the world increase, more water evaporates and then falls as rain. Some places aren't prepared for major rainstorms and floods. People there have to start building better roads, bridges, and sewer systems. They have to move away from oceans and rivers, too. However, cutting down on the amount of harmful gases released into the air because of human activities may help slow climate change. Our Earth-friendly actions may help us stay dry in the future. Earth's Hottest Places by Sebastian Witte. Extreme heat. Have you ever tried to escape the heat on a hot summer day? Probably the only thing you want to do is to find a swimming pool or an air-conditioned building. Most parts of the United States and Canada don't have extreme heat for more than a few months. That's a good thing, because too much heat is dangerous for the human body. There are some incredibly hot places around the world where people manage to survive, though. They do that by not spending too much time outside. Death Valley. The hottest place in the world is Death Valley. Death Valley is part of a national park located mostly in California. A small part crosses into Nevada. Death Valley's hottest air temperature ever was recorded on July 10, 1913. It was 134 degrees Fahrenheit, 57 degrees Celsius. Normal summer temperatures there reach 120 degrees Fahrenheit, 49 degrees Celsius. It may cool down to 90 degrees Fahrenheit, 32 degrees Celsius at night. Death Valley is also the driest place in North America. High temperatures and little water mean that the hottest parts of Death Valley have few plants. Why so hot? There are several mountain ranges separating Death Valley from the Pacific Ocean. These mountains block rain and cool air from entering the valley. Sunlight quickly heats the ground and makes it hard for plants to grow on the valley floor. Mountains on either side of the valley also act like walls and keep the heat in. Warm air rises and cools, yet in Death Valley the cooler air can't escape. It comes down and is rewarmed. This creates huge masses of hot air moving around the area. El Azizia, Libya. Before Death Valley was named the hottest place on Earth, an army base in El Azizia, Libya, held the record for 90 years. The record was 136 degrees Fahrenheit, 58 degrees Celsius, set in 1922. However, in 2012, scientists announced this temperature wasn't correct because of faulty tools. It was likely lower than the highest temperature in Death Valley. Still, Libya often records temperatures as hot as 122 degrees Fahrenheit, 50 degrees Celsius. That's because most of the country is covered by a desert called the Sahara. So most of the population of Libya lives along the coast of the Mediterranean Sea. Ground and land skin temperature. Death Valley recorded the highest air temperature in the world. These are temperatures measured out of direct sunlight, away from shade, and several feet above the ground. Ground temperatures are often much warmer because the sun's rays heat Earth's surface. In Death Valley, the highest ground temperature was 201 degrees Fahrenheit, 94 degrees Celsius, on July 15, 1972. The air temperature for that day was only 128 degrees Fahrenheit, 53 degrees Celsius. Another measurement is called land skin temperature. This is how hot a surface would feel to touch. The Lut Desert. Scientists at NASA, National Aeronautics and Space Administration, used satellites to figure out the location of the hottest land skin temperature on Earth. They collected data for 7 years and discovered that the Lut Desert in Iran was the hottest place according to land skin temperature data. There, the hottest overall land skin temperature was recorded in 2005. It was 159.3 degrees Fahrenheit, 70.7 degrees Celsius. Other extremely hot land skin temperatures were recorded in Queensland, Australia, and the Flaming Mountains of China. Timbuktu, Mali. The city of Timbuktu in Mali is one of the most famous in Africa. It's also one of the hottest. The temperature there can reach as high as 130 degrees Fahrenheit, 54 degrees Celsius. Timbuktu is located on the southern edge of the Sahara, near the Niger River. Timbuktu was founded around AD 1100 as a trading post. Gold and salt traders used it as a stopping point as they made their way across Africa. There are still buildings there that date back to the 1400s. Dalol, Ethiopia. Dalol, Ethiopia is called the hottest inhabited place on Earth. Its average yearly temperature is 94 degrees Fahrenheit, 34 degrees Celsius. It doesn't get much cooler than this even in winter. Dalol is located more than 300 feet, 91 meters below sea level. It was once a mining town, and people still mine salt there now. Warm underground waters have pushed salt, acid, and colorful minerals to the surface. Though salt is whitish, the other minerals make the salt fields look colorful. Seriously hot. In extremely hot places, people live their lives avoiding dangerous heat. For example, they stay indoors and rest during the hottest part of the day. They wear light clothing that covers and protects their body. Heat exhaustion is a condition in which a person feels dizzy or faint. Heat stroke is even more serious. Body heat rises dangerously high. It can be deadly if not treated. It's important to rest in hot weather and drink plenty of water no matter where you live. Earth's Highest Places by Mary Griffin. Mount Everest. Mount Everest is famous for its height. It's the tallest mountain in the world at 29,035 feet, 8,850 meters above sea level. Mount Everest is located between Nepal and Tibet in China. It's part of the Himalayas, a mountain range with many tall peaks. Mount Everest is so high that mountain climbers couldn't reach the top until 1953. That year, Edmund Hillary and Tenzing Norgay were the first to do so. They had to avoid sheer drops, slick ice, deadly rocks, powerful winds, and freezing conditions to get there. Danger at high altitude. Another danger of being on top of Mount Everest and other high peaks is that there's less oxygen so high up in Earth's atmosphere. There's about 1/3 less oxygen than we breathe at sea level. Low oxygen levels can cause dizziness or worse. Altitude sickness may lead to brain swelling, blackouts, and more. Most mountain climbers use bottled oxygen and masks so they can breathe more easily and avoid altitude sickness. They need to be at their best to avoid accidents, so extra oxygen is a smart idea. Highest city. People manage to live in some very high places. The magazine National Geographic gives the title of highest city in the world to La Rinconada, Peru, which is found at 16,732 feet, 5,100 meters above sea level. It's a tough place to live. Temperatures are freezing so high up. There isn't running water or a system of transporting waste away from the city. More than 30,000 people live there to work in nearby mines, searching for gold. Sometimes, as extra payment, miners are allowed to carry home whatever they can find for themselves. Mount Chimborazo. Mount Everest is the highest mountain from sea level to peak. However, it isn't the highest point on Earth. How can this be true? Earth isn't a perfect sphere. It's shaped a bit like a flattened ball. That means that a part of it bulges out a bit more. A mountain sitting on the highest part of that bulge, Mount Chimborazo in Ecuador, is thought to be the highest point on Earth. Measuring from the center of Earth, Mount Chimborazo is taller than Mount Everest by about 1.5 miles, 2.4 kilometers. Mauna Kea. There's another mountain taller than Mount Everest. It's called Mauna Kea, and it's in Hawaii. It rises 33,484 feet, 10,206 meters from base to peak. It's not said to be the tallest mountain on Earth because its base is below sea level. People only see about 13,796 feet, 4,205 meters, of the mountain rising above the ocean. The peak is the site of the Mauna Kea Observatory. Some of the best telescopes are located there because the conditions to view space from atop the mountain are so good. Building mountains. Many mountains form when the pieces that make up Earth's crust, called tectonic plates, push against each other. The force causes the matter that makes up the plates to crumple, pushing up and creating mountain ranges like the Himalayas. This process happens over millions of years and is still happening. Other mountains are formed when hot magma beneath Earth's surface erupts. This is called a volcano. Lava, ash, and rock cool and can pile up into a mountain. Mauna Kea and Mount Chimborazo are both volcanoes. Burj Khalifa. Mountains aren't the only high places on Earth. People build very tall structures. Though none are as tall as the mountains in this book, they're still extremely tall. The tallest building in the world is called Burj Khalifa, which means Khalifa Tower. It's located in Dubai in the United Arab Emirates. The builders kept the planned height a secret while construction went on. When it was completed in 2010, Burj Khalifa was 2,717 feet, 828 meters tall. It has 162 floors and is used for businesses and apartments. One World Trade Center. When One World Trade Center in New York City was completed in 2013, it became the tallest building in the Western Hemisphere. It towers at 1,776 feet, 541 meters. The glass and steel sides are meant to reflect back the colors of the sky and city lights around it. One World Trade Center is built on the site of the old World Trade Center. The twin towers of the World Trade Center were attacked and destroyed by terrorists on September 11, 2001. The new building is a sign of hope for a peaceful future, always higher. There are many other very tall buildings in the United States and around the world. However, many of the tallest man-made structures are towers built to send TV and radio signals. People are always trying to build stronger, taller structures. In 2014, it was announced that a building called Kingdom Tower would be built in Saudi Arabia. It's planned to be an amazing 3,280 feet, 1 kilometer tall. Will they succeed in building the new tallest building in the world?
Tornadoes by Doreen Gonzalez. Twisting and turning. Gray clouds roll across the sky. Suddenly, one dips low, spinning and narrowing into a tube. It waves back and forth and reaches toward the ground. The tube moves forward, whirling, swirling, and kicking up dust. This is a tornado. A tornado is a spinning column of air that touches the ground. Most tornadoes are small and weak. Some, though, can be 1 mile, 2 kilometers wide, and spin at speeds of more than 300 miles per hour, 483 kilometers per hour. Tornadoes can pull trees right out of the ground and pick up entire buildings. Tornadoes can even kill people. The right stuff. Most big tornadoes form in thunderstorms. These may form when there is a layer of warm air near the ground and a layer of cool air above that. The warm air rises and cools into water droplets, making a cloud. Then more warm air moves in. That air rises too. Winds form when it hits the cold air. Sometimes these winds blow at different speeds and in different directions. The right mix of winds can make the air start spinning in a horizontal or side-to-side tube. At times, the tube turns vertical or going up and down. If the vertically spinning tube touches the ground, it is a tornado. Ropes, wedges, and waterspouts. There are several kinds of tornadoes. Long, narrow tornadoes are sometimes called rope tornadoes. Wedge tornadoes are wide and cone-shaped. Huge thunderstorms called supercells create the strongest tornadoes on Earth. These are sometimes known as supercell tornadoes. A multi-vortex tornado has two or more tornadoes spinning around one center. The winds of the smaller tornadoes can be stronger than those of the larger cloud. Because of this, multi-vortex tornadoes sometimes destroy one building while leaving the building next to it standing. Waterspouts are tornadoes that form over warm water. Some are strong enough to turn over boats. Waterspouts sometimes move onto land and become tornadoes. Path of ruin. In May 2011, one of the deadliest tornadoes in U.S. history tore through Joplin, Missouri. This multi-vortex tornado formed in Kansas. It then moved east, gaining strength as it moved. By the time it entered Joplin, its winds were blowing at 200 miles per hour, 322 kilometers per hour. The tornado roared through the city, crushing cars and tossing buses. It knocked over trees and blew buildings apart. It took under an hour for the tornado to pass through Joplin. It destroyed nearly everything in a 6-mile, 10-kilometer-long path. Tornado Alley. The United States has about 1,000 tornadoes each year. This is more than any other country. Most U.S. tornadoes occur in an area called Tornado Alley. Tornado Alley stretches across the Great Plains from Minnesota to Texas. The land there is very flat. Cold air from Canada can flow across it quite easily. At the same time, warm, moist air from the Gulf of Mexico can easily move north. When the cold air meets the warm air, large thunderstorms often form. Many times, these storms produce tornadoes. Tornadoes are most common in Tornado Alley in the late spring. Outside the alley. Tornadoes form in places outside Tornado Alley, too. For example, the southeastern United States has many tornadoes each year. Tornadoes also strike in other countries. For example, Australia has many tornadoes. Some of the strongest tornadoes outside the United States occur in south-central Bangladesh. This is a place where cold air comes across flat land to meet warm, moist air from the Bay of Bengal. Tornadoes are a special danger to the people who live in this area. Many of their homes are made of mud and straw. Each year, the tornadoes that strike this area cause many deaths. How strong is it? Scientists estimate the strength of a tornado by figuring out its wind speed. They do this by seeing how much damage it has caused. They then rate the tornado on the enhanced Fujita scale. An EF0 tornado is the weakest kind of tornado. It can break tree branches and damage signs. It has winds from 65 to 85 miles per hour, 105 to 137 kilometers per hour. An EF3 tornado can rip roofs off of houses. The strongest tornadoes are rated EF5. An EF5 tornado can tear sturdy houses from the ground and toss cars around. Its winds blow at more than 200 miles per hour, 322 kilometers per hour. Storm chasing. Scientists want to become better at predicting tornadoes. They study them using a tool called Doppler radar. It measures spinning winds. Sometimes scientists make tornadoes in special rooms or chambers to see how they behave. People called storm chasers drive to thunderstorms in case a tornado forms. They want to be as close as possible to measure its temperatures and winds. Some people fly airplanes into storms to gather information. Scientists use all of this information to build computer models of storms that make tornadoes. Then, when a new storm forms, the models can tell them if it might make a tornado. Be smart and stay safe. Scientists at the National Weather Service watch for tornadoes. When they think one might form, they send warnings to news stations. If a tornado is predicted near you, move to a basement. If you have no basement, go to a bathroom or closet in the middle of the house. Stay away from windows. If you are outside, get in a car. If you know what to do when a tornado appears, you can keep yourself safe. Volcanoes by Doreen Gonzalez. A hole in the earth. A volcano is a hole in the ground that reaches far underground. Sometimes rocks and gas from deep underground come out of the hole or vent. This is known as an eruption. In some eruptions, hot liquid rock called lava flows from the vent. Other eruptions shoot lava high into the air. Volcanic eruptions can be fantastic to watch. However, they are also dangerous. They can cause a lot of damage. Some eruptions kill people. Eruptions can cause other deadly disasters too. For example, eruptions near the ocean or underwater can set off huge waves called tsunamis. Tsunamis can cause flooding along coasts. Bursting through. Earth's outside layer is called the crust. It is made up of huge plates of rock that fit together like a puzzle. Below the plates are rocks and magma. Magma is a rock that is so hot that it is liquid. Sometimes magma rises up between two plates. If it spills out onto Earth's surface, it causes a volcanic eruption. Erupting magma is known as lava. Volcanoes also form over hot spots. Hot spots are places where especially hot magma pushes its way up through a plate. The magma collects in a pool under the crust and sometimes bursts through. Shields and cones. Different kinds of volcanoes erupt in different ways. Shield volcanoes, for example, are low and wide. They form at hot spots. Lava spills from their holes or vents. It then cools and hardens to build a gently sloping hill. Cinder cones are cone-shaped volcanoes made when balls of lava shoot out of a vent. The force of the explosion breaks the cooling lava into small pieces called cinders. Most cinder cones have craters or bowl-like dents on top. Composite volcanoes are also shaped like cones. Both lava and rock erupt from them and pile up along their sides. Far-off effects. The biggest volcanic eruption in recorded history took place in Indonesia in 1815. Mount Tambora erupted, shooting ash 28 miles, 45 kilometers into the air, and killing about 100,000 people. The eruption created a gas cloud that blocked warmth from the sun. It made weather around the world much cooler than usual. This made crops die. Thousands more people then died of starvation. The 2010 eruption of a volcano in Iceland caused a different problem. Eyjafjallajökull erupted for 3 months, sending ash all the way to Europe. Airplanes could not fly through the ash, so air travel was stopped for days. Krakatoa. Most of Earth's volcanoes are in an area around the Pacific Ocean known as the Ring of Fire. Krakatoa, a volcano in Indonesia, is one. Krakatoa is best known for its powerful eruption in 1883. That eruption destroyed much of the island on which the volcano sat. The blast it made was heard 3,000 miles, 4,800 kilometers away. Krakatoa's eruption killed thousands of people on the island. Then it set off a tsunami that killed thousands more on islands nearby. Scientists think that ash from the eruption blocked enough sunlight to cause cooler temperatures around the world for several years. Deadly mud. Nevado del Ruiz is an ice-covered volcano in Colombia. Heat from its eruptions often melts the ice. The water this produces mixes with the material coming out of the volcano. This makes a heavy mud that slides down the mountain, washing away everything in its path. It is called a lahar. In 1985, an eruption of Nevado del Ruiz created a deadly lahar. The mud became deeper and deeper as it moved downhill. Within 3 hours, a wall of mud 130 feet, 40 meters tall was sweeping through the town of Armero. The mud buried what it did not carry away. The eruption killed 23,000 people. Forgotten towns. One of today's most dangerous volcanoes is Mount Vesuvius in Italy. It could erupt at any time, yet 3 million people still live near its slopes. Mount Vesuvius has erupted many times in the past. In AD 79, the volcano shot out so much ash and rock that the nearby towns of Pompeii and Herculaneum were buried. Most of the people living there were killed as they tried to escape. In time, people forgot about the towns. Then their remains were discovered in the 1700s. As scientists dug through the ruins, they learned much about life long ago. Volcano Watch. Several U.S. volcanoes have observatories near them. These are places where scientists can study volcanoes up close. The scientists there are always watching for movements in the ground that could mean an eruption is coming. Scientists also study the rocks near volcanoes to learn what is inside Earth. They study the gases coming out of vents, too. This helps them figure out if an eruption is coming. Working close to volcanoes is dangerous work, so these scientists must be very careful. Scientists use the information they gather to create models of volcanoes on computers and in labs. These help them understand how volcanoes act. Be ready. Scientists can tell if a volcano is likely to erupt sometime during the next few years. They are not often able to be more exact, though. If you live near a volcano, keep an emergency kit ready. It should include a mask, flashlight, and battery-operated radio. Stay inside during an eruption and be ready to leave the area if needed. Volcanic eruptions are dangerous, so always be ready to keep yourself safe.
Speeding. Mechanical Energy by Emma Carlson Byrne. Matter in motion. Imagine that you are riding a giant roller coaster, thundering down a huge hill. You are experiencing mechanical energy. Energy is the ability of a system to do work. Energy comes in forms such as sound, light, and heat. This book will explore mechanical energy, the energy of matter in motion. This is the energy that an object has due to its motion or to the possible energy the object has, even when it is not moving, resting, or moving. Mechanical energy can exist in two different states. One state is potential energy. This is the motion an object can do even though it might be at rest. For instance, picture a skateboard sitting at the top of a slope. The skateboard is not moving, so it has potential energy. If someone pushes the skateboard down the slope, it has kinetic energy. Kinetic energy is the energy of motion itself. All objects in the world have either potential energy or kinetic energy, mass, motion, and force. You know that an engine makes a car go. The car and its engine are examples of mass, motion, and force. These are important ideas in understanding mechanical energy. Mass is the amount of matter an object has. Motion is movement. Force is the push or pull applied to mass. Force is what sets the mass in motion. Imagine a car and its engine. Both the car and the engine have mass. When the engine is started, the movement of the engine supplies the force that sets the car in motion. Speed and motion. When you think about motion, the first thing you probably think about is speed. Speed is how fast an object is going, which is measured by how far it can travel during a certain period of time. For example, a pitcher might throw a fastball at a speed of 90 miles per hour, 145 kilometers per hour. This means that if the ball could travel at that speed for 1 hour, it would travel 90 miles, 145 kilometers. Acceleration is a change in speed, either slowing down or speeding up. When a car's gas pedal is pressed, the car starts to pick up speed. It is accelerating. Measures of speed. Speed can be measured in different ways. In the United States, speed is measured in miles per hour. Most other countries in the world measure speed in kilometers per hour. The speed of boats is measured in nautical miles per hour. Nautical miles per hour are also called knots. Planes and rockets often use a unit called a Mach number. This measures how fast a plane is flying compared to the speed of sound. Mach 1 is the speed of sound. The fastest speed in the universe is the speed of light, as measured in a vacuum. The speed of light is 186,282 miles per second, 299,792 kilometers per second. What is gravity? Gravity is the force that pulls all objects downward toward the ground. Picture a roller coaster rolling down a hill. The roller coaster is being pulled downward by gravity. Gravity is related to inertia. Inertia means that objects want to stay in the same state they are already in. If an object is at rest, it will stay at rest unless acted upon by a force. Likewise, objects that are in motion will keep moving unless acted on by a force that will slow or stop their movement. Friction, slowing it down. If you are riding your bike and you begin going down a hill, the force of gravity will make you pick up speed. Have you ever thought about how a bike's brakes help you slow down or stop? That is friction at work. Friction is when one object rubs against another object. This action slows an object's movement. If you look at a bike's brakes, you will see that they are little rubber pads on either side of the tire. When you use the brakes, these pads apply friction to the tire, slowing the speed at which the wheels are moving. Power and simple machines. Simple machines are mechanical devices that change the direction or the power of a force. This multiplies the force and makes it possible to do tasks that would be very hard or impossible for you to do without the simple machine. One kind of simple machine is a pulley. A pulley is a wheel with a rope on its outside edge. To use a pulley, you might tie one end of a rope around a heavy box, thread it over the pulley, and pull on the other end. The pulley makes it easier for you to lift the heavy box. Converting mechanical energy. Sometimes we can convert or change energy into other forms that are useful to us. A hand-cranked generator uses mechanical energy to create electrical energy, for example. The kinetic energy of your hands turning the crank is what powers this kind of generator. One of the most important rules of energy is that it cannot be created or destroyed. This is true no matter what form it is converted from or into. All of the energy in the universe is constantly being converted into other forms. The energy of motion. Mechanical energy is everywhere in your world. You can see it in a yellow school bus rumbling down the street, a baseball zooming over home plate, or a construction crane lifting a block of concrete. Even the flushing of your toilet in the bathroom is an example of mechanical energy. As you go through your day, look for examples of your own. Without the energy of motion, our world would be a still, silent place.
A Trip to the Sun by Claire Flynn. Let's hop into a spacecraft. The sun is so amazing. Have you ever looked up at the sky and wanted to learn more about that glowing ball? Can you imagine getting into a special spacecraft that would let you safely travel to the sun? Hope you brought your sunglasses, because that's exactly what we're going to do. Let's hop into our ship and blast off so we can take a closer look at the sun and what makes it so amazing. Miles and miles. It's a good thing our spacecraft is super fast, because the sun's about 93 million miles, 150 million kilometers from Earth. If we could hop into a car and drive to the sun at 70 miles, 113 kilometers per hour, it would take us about 152 years to get there. Once we reach the sun, it's hard to imagine just how big it is. Over 1 million Earths could fit inside it. The circumference of the sun is a whopping 2.7 million miles, 4.4 million kilometers. The sun was born. The sun was created about 4.5 billion years ago. It's not a planet, but a star. Stars are really big balls of gas. The sun is made of about 92% hydrogen and 8% helium. There are stars much larger than the sun, but the sun is the closest star to Earth, so it looks bigger. From Earth, the other billions of stars look like tiny dots of light. The sun started out much smaller than it is today. Billions of years ago, a cloud of gases and dust came together under the force of gravity. The pressure and heat increased, and the ball grew hotter and hotter. It became so hot that its core ignited, causing nuclear fusion. Nuclear fusion is the process by which stars produce their own energy. Stars change hydrogen into helium and give off energy in the process. Feeling hot, hot, hot. As our ship gets closer to the sun, we start to feel just how hot it is. The surface of the sun is about 10,000 degrees Fahrenheit, 5,538 degrees Celsius. If that's too hot for you, we'll find some sunspots. These parts appear darker on images taken by astronomers because they're actually cooler than other parts of the sun. If we were to reach the sun's core, it would get even hotter. The core reaches more than 27 million degrees Fahrenheit, 115 million degrees Celsius. But for now, let's land on the surface of the sun. The sun's 6 layers. We know the center of the sun, its core, is the hottest part. It also produces all the sun's energy. The next layer is called the radiative zone. This carries energy out from the core to the convective zone. Next comes the atmosphere of the sun, starting with the photosphere, where the light we see from the sun comes from. The 5th layer is the chromosphere, which is filled with hydrogen. The outermost layer of the sun is the corona, which is a cloud of gas and plasma. Convection. As our ship travels through the layers of the sun, you'll probably notice the temperatures are ever changing. This is due to something called convection. Have you ever noticed an attic is often hot while basements stay cool? This is because warm air rises while cool air falls. The same thing happens in the sun. As the gases in the core are heated, they rise, while the cooler gases sink back into the core. This constant circle of gas within stars is called convection. Solar winds. It's feeling a bit breezy on the sun. As the sun's core turns hydrogen into helium, it lets tiny bits of particles, or atoms, out into space. The sun's radiation and these atoms make a type of wind known as solar wind. The atoms are released away from the sun in all directions. Right at this very moment, atoms are traveling our way. The solar wind created by the sun also mixes with other stars' wind. The best light show in the universe. Back down on Earth, the solar wind can sometimes be seen as what we call the northern and the southern lights. People in some parts of the world can look into the sky and see a beautiful light show. The northern and the southern lights are caused by solar flares, which happen when the sun releases a huge amount of gases and plasma into space. When they reach Earth's atmosphere, the skies light up at night. In the northern hemisphere, these lights are referred to as the aurora borealis. Exploring our solar system. Now that we know how the sun works, let's fly our ship to the rest of the solar system. Everything in the solar system orbits or travels in a circle around the sun because of its gravitational pull. There are 8 planets in the solar system, but the sun contains 99.86% of the solar system's mass. The sun is also the only object in the solar system that makes its own light. Everything else reflects or throws back the sun's light. The sun's role in our weather. All that energy coming from the sun helps create our weather on Earth. Since Earth is almost round, the sun's rays reach different parts of it at different times and angles. Temperatures are usually warmer near the equator because it gets more direct sun. Temperatures are milder away from the equator and get very cold near the poles. Earth's orbit also causes seasonal changes: winter, spring, summer, and fall. Places having winter see colder weather, while summer weather is warmer. Ready to blow? We know the sun uses hydrogen for fuel, But what happens if the sun runs out of hydrogen? Well, when stars run out of fuel, they start to change. Yellow dwarf stars start to get bigger and turn orange. Then they grow even larger and become red giant stars. Red giant stars send out about 1,000 times more energy than our current sun, which would bake Earth and might blow away our atmosphere. Thankfully, scientists say the sun has about 5 billion years of hydrogen fuel left. We can't live without it. Now that we've learned about the sun and its role in our solar system, it's time to get back to Earth and cool off. What an amazing journey we took in our special ship. We now know that without the light and energy from the sun, all life on Earth would perish. So the next time you look up in the sky, remember how important that yellow ball is, and put on some sunscreen so you don't get burned.
A Trip Inside a Tornado by Christine Honders. Let's take a trip. You've probably seen many thunderstorms. A really bad storm can make a tornado. You may have seen pictures of tornadoes, but most people have never seen a real tornado. What if you could get on a special ship and safely see what happens in a tornado? You'd see how a tornado forms and feel how fast it moves. This book will take you on that adventure. Let's take a trip inside a tornado. Extreme weather. Weather is all around us, every day. It's something we can't control. In fact, it's so powerful that it often controls us. The weather affects what we do, where we live, and even what we wear. Very bad weather is sometimes called extreme weather. Extreme weather, such as hurricanes, snowstorms, and tornadoes, doesn't happen very often, but when it does, it causes lots of harm to buildings and roads. What is a tornado? Before going inside a tornado, we must know what one is so we can be ready. Tornadoes are nature's strongest storms. They usually come from powerful thunderstorms. Tornadoes can have winds up to 300 miles, 483 kilometers per hour. Tornadoes are so strong they can pick up cars and toss them through the air. This is one of the main reasons tornadoes are so dangerous. Tornado Alley. Let's fly our ship to where a tornado might start. The United States has about 1,000 tornadoes every year, more than any other country. Most of them happen in what's called Tornado Alley. Tornado Alley is an area that stretches from Texas to South Dakota. One reason many tornadoes form here is because the land is very flat. Another reason is that warm air from the south and cold air from the north meet here, which is perfect for making tornadoes. Before the storm. Now that our ship has taken us to Tornado Alley, let's bring it close to the ground. The air is warm and humid. Now let's go back up into the air. The air there is colder and drier. This temperature difference is known as instability. Suddenly, a warm breeze blows up from the ground and pushes our ship further into the sky. That's because the sun heated up the air near the ground, making it very light and causing it to rise quickly. This is called an updraft. The updraft carries water vapor into the atmosphere. Water vapor can't be seen, but when it reaches cool air, it forms clouds and turns into rain. The rain starts to fall all around us. As the rain falls, it pulls air down with it. The rain becomes so heavy that it creates a downdraft. The updraft and downdraft get stronger and carry the water vapor and our ship around and around in a circle. A supercell thunderstorm. When we look out of our ship's window, we see that the updraft and downdraft are going up and down in a regular pattern. They begin to twist around each other and make each other stronger. We're in a supercell thunderstorm, the most dangerous kind of thunderstorm. When we take our ship close to the ground, the wind is slower and blows in one direction. Now let's fly the ship higher. The wind speeds up and blows in the other direction. This is called wind shear. Mesocyclones. We see a vortex start to form. In a thunderstorm, the vortex is called a mesocyclone. Mesocyclones are usually 2 to 6 miles, 3 to 10 kilometers wide. Now that a mesocyclone has formed, there's about a 50% chance it will turn into a tornado. The mesocyclone gets caught in an updraft and spins faster. It reaches out of the storm cloud in a swirling funnel cloud. Rain and hail pull the funnel cloud to the ground. Now it's a tornado. The path of the tornado. The tornado follows the direction of the cloud that it came from. And so does our ship. In the United States, tornadoes move from west to east. Most tornadoes last 2 to 3 minutes, but some last much longer. The spinning winds of a tornado are like a giant vacuum, sucking up objects, trees, animals, and sometimes even people. Usually it's dangerous to fly near the tornado winds, but our ship is made of special, strong metal, so we don't have to worry. After the storm, scientists aren't exactly sure why tornadoes stop, but most think it's because the mesocyclone gets interrupted by something. It can be interrupted because it stops raining or because the air temperature changes. After the storm, we fly our ship over the tornado's path. As we look through the ship's windows, we see some houses are completely smashed and other houses are completely untouched. We hope the people on the ground had enough warning so they could protect themselves. Predicting a tornado. Meteorologists try to figure out when and where tornadoes might form. When weather conditions may result in a tornado, meteorologists announce a tornado watch. When a tornado has been spotted, a tornado warning is given. The sky might be blue when a tornado watch is given, but don't be fooled. Tornadoes can strike with little warning. Before they form, the wind dies down, and the air can become very still. You should watch the sky for a greenish color or low, dark clouds. Be prepared. Now that the storm is over, let's land our ship so we can help. Why are people coming out of their basements? That's because the first rule of tornado safety is to go to the lowest part of your house. If you don't have a basement, go to a windowless inside room, such as a closet. If you're outside when a tornado hits, you should lie down in a ditch. Always protect your head. If you're in a car or mobile home, leave and find the nearest sturdy building. That's an extreme trip. What an adventure! Our ship started in a thunderstorm and ended in a tornado. The whole trip only took a few minutes. Isn't it amazing that such extreme weather can happen so quickly? Even though very few thunderstorms turn into tornadoes, they can happen anytime and anywhere. Next time, you won't have our sturdy ship to protect you. So if you see a funnel cloud, remember our trip inside a tornado. You'll know what to expect and how to keep yourself safe.
A Trip Through the Human Body by Christine Figueredo. Our amazing bodies. Our bodies do incredible things. We run, jump, sing, and shout. At the same time our heart is beating, our lungs are helping us breathe, and our stomach is growling. Do you wonder why our bodies do all these things? We're going to find out. Imagine you can shrink yourself until you're as small as an ant. Now, get into our special tiny ship. It's so small it fits into an ear. We're going on a trip through the human body. Anatomy of the human body. The human body is amazing. Humans are many different shapes and sizes, but we all have the same basic body parts. The study of these parts is called anatomy. The body is divided into systems. Each system has a very important job, and the systems work together to keep you thinking, breathing, and moving. Let's start up our ship and get ready to explore some of these systems together. Let's fire up the engines and take off. Your body's computer. We're going to explore a man named Marty. He's going to let us take our ship through his body. We fly into Marty's ear, but we're so small he can't even feel it. The first thing we see is a pinkish-gray wrinkled organ. That's his brain. The brain works like a computer. It tells all the other parts of the body what to do. The brain is inside the skull, which is the name for the bones in the head that protect the brain from getting hurt. Marty's brain weighs about 3 pounds, 1.4 kilograms, the size of most adult brains. It has 3 main parts. The top part, called the cerebrum, is the biggest. It has cracks and folds and is the thinking part of the brain. The cerebellum is in back, tucked under the cerebrum. It controls balance and movement. The third part, called the brainstem, is at the bottom of the brain. It controls things like breathing, heartbeat, hunger, and pain. A bunch of nerves. Marty's brain can't run his body by itself. At the back of the brain, you'll see a long bunch of nerves that runs down his back. This is called the spinal cord, and with the brain, it makes up the first system we see on our trip, the nervous system. Nerves are made up of neurons. Neurons send messages back and forth from Marty's brain to all parts of the body. The body contains billions and billions of neurons. Down the spine. Let's follow Marty's spinal cord in our ship. Even though we can't see them, neurons are sending messages back and forth from his brain to his body at about 200 miles, 320 kilometers per hour. Suddenly, our ship starts to move up and down. Marty's arm is moving. His eyes must have seen someone he knows, and his brain told his hand to wave hello. Neurons carry this message, but something else is making his arm move. We'll turn our ship to find out. Move those muscles. Marty's arm wouldn't be able to move without muscles. Muscles give the body power. They're made up of stretching tissue, like the stuff that makes rubber bands. They work by tightening and relaxing. There are 3 kinds of muscles. Skeletal muscles move the parts of the body that make us run and jump. Cardiac muscles are muscles in the heart that keep it beating. Smooth muscles move food through the body, control the blood vessels, and help the body go to the bathroom. Oh, them bones! Muscles are rubbery, so how does Marty's body stand up straight? Skeletal muscles are attached to his bones, which make up the skeletal system. We see something like ropes connecting Marty's arm muscles to his bones. These ropes are called tendons. Marty's bones work with his muscles so he can wave. His brain sent a message through neurons to his arm muscles, which answered by moving his bones to make him wave. These bones also keep Marty's organs safe, the heart and lungs. We take our ship to Marty's chest and see a pear-shaped object. This must be the heart. The heart is made of cardiac muscles that pump blood through your body. The heart is 2 pumps in one. The right side gets blood from Marty's body and sends it to the lungs. The left side gets blood from the lungs and sends it back into his body. Lungs take waste gases out of Marty's blood, and the gases leave Marty's body when he breathes out. The journey of Marty's lunch. In the middle of Marty's body is a long tube that starts in his mouth. Let's follow this tube, which is called the esophagus. Marty must be eating lunch because food is moving from his throat down to his stomach. His stomach is a stretchy sac that looks somewhat like the letter J. It's like a mixer, smashing food into tiny pieces. Special juices in the stomach help break down food and kill bacteria in it. On the way out, let's follow Marty's lunch as it moves through his digestive system. The food leaves the stomach and goes to the small intestine. It looks like a long tube bunched under Marty's stomach. It breaks down the food even more so his body can take in the fuel he needs to live. The large intestine is food's last stop. It takes what's left of the food, the part the body can't use, and pushes it out as waste. It comes out when Marty goes to the bathroom. Cleaning up. Our ship also takes us to other parts of the body that collect wastes. We see the liver and 2 kidneys. They help clean Marty's blood. Glands are all over the body and make things called hormones, which are chemicals that make the body do different things. Now it's time to leave Marty's body. Outside, we see the biggest organ of all, the skin. It covers and protects everything. Without skin, his bones, muscles, and organs would be hanging out. Keep it running. You need to keep your body in good shape. It's important to get some exercise every day. Exercise keeps you strong and full of energy. You also need to eat healthy foods to give your body the energy it needs. Checking out Marty's insides showed us how everything works together. Your brain tells the other organs in your body how to work, but each part has an important job. Thanks for coming on our trip through this amazing machine.
Floods and Tsunamis by Doreen Gonzalez. Out of control. All living things need water. This water comes from rain and snow. It is found in rivers and lakes, too. Sometimes the amount of water gets out of control, and a flood happens. Rivers and lakes become so full that water spills over their banks. When dams give way, the water they hold back pours out. Floods are not always harmful. However, some ruin buildings and kill animals. Floods can even kill people. Ocean water can also become wild. Huge waves called tsunamis wash across beaches onto the land beyond. They sweep away people and buildings. Landslides, volcanoes, and undersea earthquakes can all cause tsunamis. Water, water everywhere. Many things cause floods. Water from rain flows into rivers and lakes. Long or hard rains sometimes fill these bodies of water. Once they are full, if more rain falls, it has nowhere to go. It runs on to nearby land. Melting snow can also cause flooding. Melted snow flows to rivers and lakes. If snow melts too quickly, they can flood. This often happens when a lot of snow is followed by several days of warm weather. Storms called hurricanes can cause flooding too. Many bring heavy rains. Their strong winds can push water from oceans or lakes onto land too, in a flash. Flash floods are floods that happen suddenly. Flash floods are common at the bottoms of mountains and hills after heavy rains. Water runs quickly down these slopes and pools at the bottom. Many flash floods happen in canyons and other places where rain is funneled into narrow areas. Heavy desert rains can also create flash floods. Desert soils cannot take in much water. Rainstorms in cities can cause flash flooding in places like underground parking garages. When a dam breaks, it can also cause a flash flood. Water rushing over a broken dam can pour into the area below quite suddenly. Floods from the ocean. Storm surges cause coastal floods. A storm surge happens when winds from hurricanes or other storms push water onto the shoreline. Strong hurricanes can make storm surges over 25 feet, 8 meters high. Tsunamis can cause coastal floods too. Tsunamis strike coasts with little warning. Some are not very high at all. Others can be 100 feet, 30 meters tall. Tsunamis can move up to 600 miles per hour, 965 kilometers per hour. In 2004, an earthquake rocked the floor of the Indian Ocean near Indonesia. It set off one of the worst tsunamis in history. Within an hour, waves hit seacoasts all around that ocean. Tsunami in Japan. In 2010, an earthquake that shook the sea floor off Japan created a powerful tsunami. Its waves reached 30 feet, 9 meters. Ocean water rushed across Japanese beaches and through cities. It carried away cars, buildings, and people. Dams burst and power lines were knocked over. Quickly flowing water destroyed parts of nearby nuclear power plants. Radiation, a form of energy that can make people sick, leaked from them. It will be many years before scientists know how many people were made sick by the radiation. The tsunami itself left almost 20,000 people dead or missing. Thousands more were left without homes. Again and again. Some areas have had many floods. The Yellow River in China has flooded for centuries, killing millions of people. The river's waters are full of silt. This fine dirt falls to the river bottom, building its bed higher and higher. Water flows from the high parts onto nearby land. Today, dams and high banks called dikes control the flooding. The Netherlands has also had many floods. Much of this country lies below sea level. People there once built dikes to hold the ocean back. These dikes often gave way and caused deadly flooding. Today, strong dams keep the Netherlands dry. The Johnstown flood. One of the worst floods in the United States happened in Johnstown, Pennsylvania in 1889. Johnstown sits in a valley of the Allegheny Mountains. That year, a spring thunderstorm filled a lake above the town. The water pushed against a dam and made it weak. Then the dam burst. Water poured out of the lake and down the mountainside. Within an hour, a wall of water was rushing into Johnstown. The water swept through the town, taking people and buildings with it. The flood killed more than 2,000 people. Watching for water. One way that scientists study floods is by building computer models of past floods. This helps them predict how future floods might behave. The National Weather Service closely watches rivers that might flood. It sends out warnings to officials and news stations where flooding might occur. Scientists at tsunami warning centers Watch for undersea earthquakes using instruments called seismographs. When an undersea earthquake happens, they look for signs that a tsunami is forming. They use information sent to them by special sensors in the ocean. They can also track tsunamis with satellites in space. As soon as possible, they send warnings to the places where tsunamis could hit. Keep safe. Too much water can be deadly. During a flood, never walk through water that is deeper than your feet. Stay away from ditches and storm drains. Move to higher ground. Listen for tsunami warnings when you are near the coast. An unusual rise or fall in ocean waters can be a sign that a tsunami is coming. If this happens, move away from the beach. Knowing what to do can keep you safe in a disaster.